Okay, so hello and welcome back. So in the previous videos, we talked a little bit about some of the formulas related to trigonometric identities and so on that we were supposed to have done in the previous chapters of the book, class 11. Now, as it turns out, we do need those formulas here because there is basically the properties of some inverse trigonometric functions, and in order to be able to derive those formulas, we need a couple of identities that we did in chapter 3 of class 11. I suppose that was chapter 3. So now let's discuss that briefly here so that we have the formulas, and so we can use them hopefully in the next video. So basically in the previous video we said that we had basically a couple of identities, like for example the sine of negative x, which is equal to the negative sine of x. We had the cos of negative x, which is equal to cos of x. And we discussed why that is, basically all of these 6 formulas. So we had the tan of negative x is equal to negative tan of x. We have the cot of negative x is equal to negative cot of x. We have the secant of negative x, which is equal to secant x, and we have the cosecant of negative x, which is equal to negative cosecant x. So that is basically all about these 6 formulas, and we talked about them. Next, what we discussed was basically cos of x plus y. Cos of x plus y is equal to cos x cos y minus sin x sin y, if I'm not mistaken, minus sin x sin y, right? So the way that basically you need to the proof for this trigonometric identity is using a unit circle. So you need to basically, we will need to do a simple unit circle here, and basically if I do the unit circle this way and select the border here and put some colors into it, and then if I basically, now I need basically 2 angles in here, the angle x and angle y, because I have 2 angles over here. I have the angle x, so I'm going to go 15 degrees here and call this angle x, and angle y I'm going to go, so this is 15 degrees, and so you have 90 minus 15 is equal to 75, and I'm going to go another 75. So if I go for example 15, 30 degrees here, so that means that then 75 plus 30 is equal to 105 degrees. 105 degrees, that I'm going to call y. So that means that y is equal to the angle y is equal to 105 degrees, and the angle x is equal to, actually I probably could have taken that a little bit different, meaning that So what I mean is that, for example, instead of 15 degrees, I could go for 30 degrees. So that's 75 plus 45, for example. 75 plus 45. 75 plus 45 is 0, and then you have 1 here, 120 degrees, right? So this angle y over here is y, this is angle y. So the measure of the angle y is equal to 120 degrees. In case we need them later, the measure of the angle x is 90 plus 15 is equal to 105 degrees. 105 degrees, and then we need the angle negative x as well. So the angle negative x, I'm going to create it using this color here. The angle negative x, I'm going to create here. So I'm sorry, negative y. So negative y is going to be negative 120 degrees. So I have to go, this is 90, and then I need to go another 30 in this direction. So that's going to be, that is going to be negative y, right? So this angle over here is negative y, starting from here, going all the way up to here is negative y. And this angle over here, this is x. This angle is x. And then we have the angle y over here. We have the angle y over here, which is basically this angle. Right, so this is y. Now, well, what I can do is that I can pick a couple of points. I can create a couple of points here. For example, there is this point over here that I can call, for example, P4. I can call P4. And the coordinates of this point is 1, 0. I can pick another point over here, this point here, which I can call, for example, P1. And that is basically the x coordinate of this point is cos of x, and the y coordinate of the point is sine of x. That is cos of x and sine of x. I have another point over here, let's call it, for example, P2. P2, the coordinates of this point are, basically P2, let's call this P2, and the coordinates of this point are basically, this angle over here is actually nothing but x plus y, right? So that basically the x coordinate of this point is sine of x plus y, and the y coordinate of that point is cos of x plus y and sine of x plus y, right? So you have the cos of x plus y, and you have the sine of x plus y, right? So that is point P2. Then I have another point over here, which is the angle negative y. So if I call this point, for example, P3, then I can write P3 as basically the cos of basically negative y, the cos of negative y, and the sine of negative y. Okay, so that is basically that, and that is basically, you can of course call these You can of course call this the y-axis, you can of course call this the x-axis, and so on and so forth. Now in this construction, the angle, basically we have some angle over here, P4O, P1, P4O, and let's call this point O. That's P4O, P1, that is angle X. So I can say that let the angle P4O, P1 be X, and P1O, P2 be Y. So P1O, P2 be Y. So let the angle P1O, P2 be Y. And then X plus Y is the angle P4O, P2. So P4O, P2, this whole angle would be X plus Y as we have indicated here. So then the angle P4O, P2 is basically X plus Y. Also, negative Y is the angle P4O, P3. Let P4O, P3 be negative Y, right? And therefore the coordinates of the coordinates of P1, P2, P3, and P4 are, so the coordinates of P1 would be cos x sin x, P1 would be cos x sin x, P2 would be basically P2 would be cos of x plus y, comma sine of x plus y. P3 would be cos of negative y, comma sine of negative y. And P4 would be basically this point over here, which is 1, 0. So that is basically that. Now we have a couple of triangles here. We have a triangle P1O, P3, P1O, P3, which is basically this triangle over here. P1O, P3. So you have this triangle P1O, P3, and we have another triangle P2O, P4. P2O, P4. So P2O, P4, which is this triangle over here. So you can see that P2O, P4 is this triangle. So you have the triangle P2O, P4, right? Now, as you can see, these two triangles are congruent because basically so we are talking about P1O, P3, which is P1O, P3, which is this triangle over here, and we are talking about and we are talking about P2OP4. So P2OP4 is basically this triangle over here. So you can see that basically the angles that they have here, first of all, they share this angle. So this angle is, if I call it, for example, alpha, the triangle you can basically P1OP3 would be some triangle like this, for example, right? And this is point O, and this angle is a combination of this smaller angle that you can call alpha and this bigger angle, which is basically Y. The other triangle, as you can see, you have the same angle alpha and you have the same angle, well, negative Y, but it has the same measure Y. Therefore the two angles between the two triangles are exactly have the exact same measure. And then one more thing, that the sides, basically, for example, OP1 and OP3 and OP2 and OP4 are all equal. So then you can say that these two triangles are congruent, and based on the congruency rule of basically side angle side, SAS, side angle side. And what that means is that P1, you can say that P1 P3 is equal to P2 P4, and therefore P1 P3 is equal to P2 P4, and this is called basically CPCT, meaning that common parts or corresponding parts of congruent triangles. Corresponding parts of congruent triangles. So we write that as CPCT, meaning that because the two triangles are congruent, then you can say that, for example, this side, since this side corresponds to this side, therefore you can say that the two sides are equal in length. Now, basically you are familiar with the distance formula. The distance formula is basically, if you have, is basically AB is equal to the square root of x2 minus x1, I suppose, x2 minus x1 whole squared, plus y2 minus y1 whole squared, if I'm not mistaken. I don't actually remember the formula. Let me check, see what the formula was here. Yeah, x2 minus x1 whole squared plus y2 minus y1 whole squared. Yes. So meaning that if you have basically, if you have some point A, for example, in a coordinate plane, you have some point A with the coordinates x1 comma y1, and you have some other point somewhere else in the coordinate plane, the point being B as x2 comma y2, then the distance between the 2 points can be calculated using this formula: x2 minus x1, the square root of x2 minus x1 whole squared, plus y2 minus y1 whole squared. And of course, since these are being squared, then of course you can write it the other way around as well, meaning that you can write AB is equal to the square root of x1 minus x2 whole squared plus y1 minus y2 whole squared. That that would give you also the same result, because you are raising this to the second power, so it doesn't really matter whether you write x2 minus x1 or x1 minus x2. Now I'm going to take this form of the formula, and so since we said that these two distances are the same, so I'm going to calculate, first of all, I'm going to calculate P1, P3. So if I calculate P1, P3 whole squared, so this formula you can raise both sides to the second power, and then you can write it as AB squared is equal to x2 minus x1 whole squared plus y2 minus y1 whole squared, right? So then, based on this formula, I'm going to calculate P1, P3 whole squared. P1, P3 whole squared. So P1, P3 whole squared is the same thing as, so P1 and P3. So this is P1, this is P3. Now, x2 minus x1 would be cos of negative y, and cos x, cos negative y, and minus cos x whole squared. They have actually written this the other way around, so I'm going to do the same thing, meaning that instead of cos of, first of all, you can instead of writing cos of negative y, you can simply write cos of y, because you know that the cos of negative y is actually equal to the cos of y, right? Which means that I can basically write, instead of cos of negative y, I can write cos of y, and so I can write cos of x minus cos of negative y whole squared. So let me write it that way. So cos of x minus cos x minus cos negative y whole squared plus y2 minus y1 whole squared would be cos x, so sin x minus sin negative y, sin x minus sin negative y whole squared. And so I can write this as basically the cos of x minus cos of negative y. I can simply write it as cos of y whole squared plus sin x minus, now sin negative y is equal to negative sin y, and negative into negative would be then positive, so you get plus sin y whole squared. And so if you expand these, you would get the cos squared x plus cos squared y minus 2 times cos x cos y plus sin squared x plus sin squared y plus 2 times sin x sin y. Now cos squared x plus sin squared x is equal to 1. Cos squared y plus sin squared y is equal to 1. Negative 2 cos x cos y sin x sin, so plus 2 times. So over here what remains is that negative 2 times cos x cos y plus 2 times sin x sin y. So I can write this as 2 times plus 2 times basically sin x sin y sine x sine y plus or minus cos x cos y, right? So that is 2 times sine x sine y minus 2 times cos x cos y. Now I can write this as 2 plus 2 times sine x sine y minus cos x cos y, and then I can write this as I can basically change the order here and take a negative out, and so I can write it as 2 minus 2 times cos x cos y minus sine x sine y, right? So that is P1 P3 whole squared. Now the next part that we need to calculate is P2. The next part is P2 P4. Where was that? Somewhere over here, P2 P4 whole squared, right? So I'm going to calculate. I'm going to make a screenshot here. And what happened? Okay, so now I'm going to, let's create a new layer here. 278. Okay, so now to calculate P2 P4, Now here what we said was that basically the coordinates of the point P2 and P4 were, so the point P2 was cos of x plus y, and sine of x plus y, and P4, the point P4 was 1, 0, Now P2 P4 whole squared, so we said that the distance formula was AB, let's say AB squared is equal to x2 minus x1 x2 minus x1 whole squared plus y2 minus y1 whole squared, right? Now so then based on this you can say P2 P4 whole squared is equal to basically x2 minus x1 would be 1 minus cos of x plus y, 1 minus cos of x plus y whole squared plus y2 minus y1, so 0 minus sine of x plus y whole squared, which is the same thing as so the 1 squared is equal to 1 plus cos squared x plus y negative 2 times cos of x plus y, and then over here you have sine squared x plus y, Now sine squared x plus y plus cos squared x plus y is equal to 1, and then 1 plus 1 is equal to 2 minus 2 times cos of x plus y. 2 minus 2 times cos of x plus y, right? Now, of course, we know that basically since P2, P4 is equal to what we calculated before, which was P1, P3, therefore, since these two basically are the corresponding parts of those two congruent triangles, and these are equal based on that. So then, since these two are equal, then you can say that P2, P4 squared is equal to P1, P3 squared. And we calculated P1, P3 squared. P1, P3 squared as P1, P3 squared we calculated as 2 minus 2 times cos x cos y minus sin x sin y right? And P2, P4 squared we calculated to be this P2, P4 squared we calculated to be 2 minus 2 times cos of x plus y, right? So which means that basically I can equate these two together because these two are equal, meaning that I can write 2 minus 2 times cos x cos y minus sin x sin y is equal to 2 minus 2 times cos of x plus y. And then 2 and 2 you can cancel out from here and divide both sides by negative 2. You can cancel these two out as well. And so you have cos of x plus y is equal to cos x cos y minus sin y. That means that cos of x plus y is equal to cos x cos y minus sin x sin y. That is the result that we were looking for, right? Now, so this is basically the very basic formula that we need, and now based on this we can basically do a whole bunch of things, really. Okay, so now in this formula, what you can do is that if I call this number 1, for example, so in 1, if you replace y with negative y, we have basically cos of x minus y is equal to cos x cos negative y minus sin x sin negative y. And you know that sine of negative y is equal to negative sine y, and cos of negative y is equal to cos y, right? So then I can write cos of x minus y is equal to cos x cos y, and then basically sine of negative y becomes negative sine y. Negative into negative is positive, so plus sine x sine y, right? So that is basically another formula that you can use. That is number 2. And then if you use any of these, for example this formula here in 2, if you set x to if you set x equal to pi by 2, if you set x equal to pi by 2 and y equal to basically x, we have, so you set x is equal to pi by 2 and set y equal to x. Of course, this is not the same x that I've written over here. My notation is a little bit problematic, but you understand what I mean. So if I set, so then basically we have cos of x is equal to pi by 2 and y is equal to x, so minus x. So wherever you see x, you have to write pi by 2. Wherever you see y, you have to write x. Is equal to cos of pi by 2 cos of x plus sine of pi by 2 sine of x. Now cos of pi by 2 is equal to 0, so this whole thing becomes 0. And sine of pi by 2 is equal to 1, so that's equal to sine x. Therefore cos of pi by 2 minus x is equal to sine x. I can call this number 3. So cos of pi by 2 minus x is equal to sine x. And in this formula, in 3, you can replace x by pi by 2 minus x. Pi by 2 minus x, we have, so that becomes sine of, instead of x you write pi by 2 minus x, and over here we will have the cos of pi by 2 minus x becomes pi by 2 minus x, which is equal to the cos of pi by 2 minus pi by 2 plus x. These two will cancel out, so you have cos of x. And therefore the sine of pi by 2 minus x is equal to cos of x. And so you can call this number 4, right? So these are all the things, all things that you can use wherever you go in trigonometry. You will be able to use them. Now, in basically, now, in order to calculate, basically, here we said that cos of pi by 2 minus x. Here we said that cos of pi by 2 minus x is equal to sine x, right? So number 3, we had cos of pi by 2 minus x is equal to sine x, which means that basically I can write here, if you replace x with x plus y, x with x plus y, we have basically cos of pi by 2 minus x plus y is equal to sine of x plus y, right? Sine of x plus y. And so what that means is that the cos of basically pi by 2 minus x minus y no, I'm sorry, I have to make a couple of arrangements. So I can write this as pi by 2 minus x plus y, I can write it that way, is equal to sine of x plus y. Now over here we said that cos of pi by 2 minus x, or basically this is cos of x plus y. We said that cos of x plus y is equal to cos x cos y minus sine x sine y, which means that I can write this as the cos of basically x, which is pi by 2, cos of pi by 2 minus x, and then cos y would be cos y here, minus sine of pi by 2 minus x sine y, right? Now, cos of pi by 2 minus x is equal to what? Cos of pi by 2 minus x is equal to sine x. Cos of pi by 2 minus x is equal to sine x. And sine of pi by 2 minus x, is equal to cos x, right? So I can write this as and this is equal to, of course, sine of x plus y, right? So now cos of pi by 2 minus x is equal to sine x cos y minus sine of pi by 2 minus x is equal to cos x sine y, which means that sine of x plus y, and that is equal to sine of x plus y, right? Which means that sine of x plus y is equal to sine x cos y minus cos x sine y. That is the next formula that we can use. So that is number 5. Now in number 5, if you replace y with negative y, we have sine of x minus y is equal to sine x cos negative y minus cos x sine negative y, which is equal to sine x cos of negative y is equal to cos y, sine of negative y is equal to negative sine y, negative comes out, multiplied by this becomes cos x sine y, which means that sine of x minus y is equal to sine x cos y plus cos x sine y. That is number 6, right? That is number 6. And then there is also a couple of formulas that, so basically in order to we can actually take a as a summary, we can, now I have lost my mouse here. Okay. Now, to do a summary of these, let me make a couple of screenshots here. We will write up a summary, and then and then so I think the previous formulas I already remember. Now this is cos of x plus y, cos of pi by 2 minus x, pi by 2 minus x, and so on and so forth. Okay, so I already remember all of them. So basically what we had so far was basically the sine of negative x is equal to the negative sine of x. We had the cos of negative x is equal to cos of x. Cos of negative x is equal to cos x. Tan negative x is equal to negative tan x. Cot negative x is equal to negative cot x. Secant negative x is equal to secant x, and cosecant negative x is equal to negative cosecant x. That's basically, that is one group of formulas that you can remember and use. These are the kinds of things that you need to remember. Moreover, we had 4 formulas related to sine cos of x plus y, x minus y. So we started with basically cos of x plus y, which was basically cos x cos y minus sine x sine y. Then we had cos of x minus y, which was equal to cos x cos y plus sine x sine y. Then we had sine of x plus y, which was equal to basically sine x sine y. No, I'm sorry, sine x cos y plus cos x sine y. Then we had basically the sine of x minus y, which is sine x cos y, sine x cos y minus sine x cos y minus cos x sine y. That is a second group of formulas that you need to use, you need to remember and use. So if you have to write them down and remember them, please do so, because you do need them. You do need them in wherever you go in trigonometry. You do need them. The third group of formulas that we had so far was basically cos of pi by 2 minus x is equal to sine x, and sine of pi by 2 minus x is equal to cos x. And that is the third group that we discussed, right? So that is that. And now we have a couple of formulas that we can derive based on the formulas that we have already derived. We will derive them in the next video. I'll see you in the next video. Thank you.